There we go. 5F. Let's begin. Now, 5F, arguably, you can memorize a certain formula and you'll be able to do it. I find that if you understand what's happening, then it's easier to work with harder problems. But I've seen in the past that, I think it was last year or the year before, when I taught some students in the library, they really struggled with the idea of completing the square. And I think it's just that new concept-ish. So I'm going to try to give you an overview of why it works. And then if that doesn't make sense, you can memorize. Yeah? Here we go. It all comes back to the very first exercise you did. It was exercise 5A, expanding. So let's remind ourselves. A plus B squared. What was the formula again to quickly expand this bracket? Yes, Yuna. Beautiful. So let's practice it then. Let's recap on 5A. Toby, can you expand this for me quickly? Go. X plus 3 squared.
X squared plus 2x 3 plus 3 squared.
Beautiful. So this is the layout, but let's write out the equation. So he said 2x3, but that just means 2 times x times 3. So that simplifies to 6x. Very good. And then plus 3 squared, which is 9. So your equation is x squared plus 9x plus, 6x plus 9. Let's do a few more so you can see a pattern, because there's a pattern that's happening. Let's do the next one. X minus 4 squared. What does that give me? Let's go with Jada. X squared minus 8x plus 16 is correct. And the same thing again. I'm going to write out the clarity of what's happening here. So I'm using the rule. So yes, you're right. X squared minus 8x plus 16. Let's go with the next one. X plus 5 all squared. Joanne? X squared plus 10x plus 25. Beautiful. So this again, 2x times the 5 plus 5 squared. So far, so good. Let's work backwards now. Because as you're working backwards, you should see a pattern. Let's say I gave you x squared plus 6x plus 9. What goes inside the brackets over here? Can I please have Sean? X plus 3, which obviously we already did it. So you should have known x squared plus 6x plus 9 should have gave you x plus 3 in the brackets. But if I changed it now, you see, how do we know it's x plus 3? There is a pattern. That 6 is always double of 3. Negative 8 is always double of negative 4. And 10 is always double of 5, which makes sense because in your calculations, that's what you did. You did double 5, double negative 4, double 3 to get the middle number. How do you get the last number? Was always squaring whatever that number is. So inside the brackets, you always double that to get 6, and you always square that to get the 9. So you can see that relationship. Double this to get that, and square that to get this. So we're working backwards now. Let's work out this one. I want a perfect square. That's what this is called. This is called a perfect square, because the formula is called expansion of perfect squares. So I want to know what goes inside this bracket if this is a 4x. So what should go inside the brackets there? Can I please have Raha? X plus 2. Because we know that half of the 4x will give me that 2. Because I had to double 2 to get the 4. And then to get the last number, I needed to square the 2. So what's inside, or what's the missing number over here? It should be plus 4. Very good. So following that same pattern, what should go into the brackets over here for x squared minus 12x? Let's go with Yuna. X minus 6. But if this is x minus 6, Sam, what should the last number be? 36. Because we're squaring the negative 6. So double negative 6 gives you negative 12, and then square the negative 6 should give you 36. This is called a perfect square. Why? Because essentially you're saying you've got an x minus 6 length by an x minus 6 length. So together the area is an x minus 6 square. So it's the area of a square. So it's a perfect square. That's why the name of that particular equation or expression is called a perfect square, right? What you're doing today is called completing the square, meaning you're going to get an expression that isn't a perfect square. It's not going to be a nice perfect shape. It could be a perfect square with an extra area. It could be a perfect square with a missing area. That's why what we try to do is we say, well, it's not a perfect square, but if we did have a perfect square, what would it look like? So this is what we're doing. Let's take this example. Here we go. Let's do this again. X squared minus 12x. Logically, if this was a perfect square, because we want this to be a perfect square, if that's a minus 12x, what should go inside the brackets? Let's go with Angelica.
For the perfect square.
Yeah, so we're seeing a negative 12. Then what number should be here to get that negative 12?
6.
Very good. So it should be a minus 6, so x minus 6. But if this is an x minus 6, here's the problem. To get the last number, we have to square the negative 6. That was the pattern. Now square of negative 6, what do you get? 36. So it doesn't make sense. This equation right here, or this expression, is not this. It's not a perfect square. I've got a plus 40 instead of a plus 36, which is what I want. So the logic here, when they say, let's make a perfect square or complete a square, what they're saying is, well, unfortunately, I have this plus 40. I'm just going to fix this again. I'm just going to fix this bit. What I wish I had was plus 36. That's what I wish. Because if I had that, then what Angelica said just now, that is correct. X minus 6, that's a perfect square. That's true. What's the problem? I don't have a 36. I have more than 36. In fact, I've got 40. So not only is this a perfect square with an extra missing bit, because I'm extra 4 units at the moment. So what we do as a technique is we say, all right, this is what I wanted. I wish I had a 36. So what they did is they say, all right, well, I wish I had a 36. So why don't I just add in the 36 to this equation? So I add 36. But if I add 36 to something that never existed, I minus 36. You see what I'm doing? Because adding 36 and minus 36, technically, it was never there. And I still have x squared minus 12x plus 40. So why do we add the 36? It is because visually, this is a perfect square. This is the missing amount. Negative 36 plus 40 now gives me plus 4. So what does that mean on a visual aspect? This means I have a perfect square where it's x minus 6 with an extra area of plus 4. I'm in a surplus. That's what that is. And the benefit of doing it through this way is you've actually just factorized. See, notice here you had 2 x's. Solving for 2 x's is a problem. Mathematically, we can't solve it, or we find it harder to solve. But here, you only have 1 x now, which is much easier to solve. Okay, that's why we do that technique. So this is a second technique, and it also puts it into a turning point form. See, now I can say up by 4 to the right by 6, smiley face, so I can already picture what this parabolic shape looks like. So this technique, up until this step, is called completing the square. Okay, so all I did was, maybe I'll color code it again. I'll do it in black. What's in black is what we actually started off with. X squared minus 12x plus 40. All I did was added on that squared number that I wanted, wish I had, then I subtracted. Why did I do that? Because visually this is a perfect square. This is the leftover. Up until this step, this is called completing the square. So when you change general form to a turning point form, up to this step is called completing the square. Okay? If they ask you to factorize and all that, that's the steps afterwards. Okay? They said solve for completing the square means from here onwards. But up until this step, that's completing the square. All right? So today's lesson is about practicing to get to this step. Turning every general equation into a turning point form. Okay, so this is a turning point form. TP form. Let's do another one just so you get a feel of it, okay? So flip over the page. Let's flip over the page. Let's do it again. So at the moment, I've got x squared plus 6x. I've got a minus 1. What number should be at the end in order for this to be a perfect squared. So I want this to be a perfect square. So that last number matters. Now, if that's a 6, you can work out what's in the brackets. Think about it, Jaden. X squared plus 6x, what goes into the brackets here? 3. So it should be x plus 3. That would be a perfect square. But if this is a plus 3, what number am I missing? 9. Very good. This number that I wish I had should have been a plus 9, which I don't have. That plus 9 is what I wish I had because then it makes it a perfect square. But that plus 9, because I made it up, I put it in, I have to subtract it. Because technically that means it never existed. But by putting it in, it changes it visually. This is now a perfect square. This is telling you what's left over. Minus 9 minus 1 gives you now minus 10. This, you have moved from a general equation to a turning point form. You can read the equation by saying down 10, left, right, smiley shape. Okay, so that's 7a, 7b. 7a, 7b was about you being able to read the turning point form. That's your general form. And right there, that's the completing the square method. How do we feel? So far make sense? Good. All right, let's try the next one. All right, let's do it again. X squared minus 4x, and you got a plus 7. That's what we currently have. Ideally, I want one that is going to be a perfect square. So I need to figure out what should the last number be so I get a perfect square. But to do that, you just need to work out what's inside the brackets first. So again, if you got x squared minus 4x, what should the number be, Michelle? 2. Very good. It's a negative 2 as well. So in this case, it's x minus 2, because double of negative 2 gives you negative 4. That means the last number must be what, Rowan? What's the missing number that I need? If this, so this one here. So that's x squared minus 4x. I want it to be a perfect square. So what would the number here must be? Plus 4. Very good. It's square of that number. So square of this number will tell you what that last number should be. Double of this will give you that. Yeah? So here we go. That's a plus 4. So the question is, if it's plus 4, it's something we didn't have. So we're going to now minus 4.
So I think we're meant to be outside the fire truck outside of school and everyone just went.
But there wasn't an alarm.
There's a fire truck. There's a fire truck and everyone's gone.
Really? Wait, give me... All right, we're back. So we got up to this bit where we said x squared minus 4x plus 4 was x minus 2 squared. That's your perfect square. Here's your missing bit. Negative 4 plus 7 gives you plus 3. Now, notice the question says factorize by completing the square. Up until this step, this is completing the square, but you haven't factorized yet. Okay? But there is only one scenario that you can factorize further and one scenario you can't. And I want you to be able to tell me why and what's the reasoning. So think about it. Which one can I factorize further and which one can't I factorize further? Is it the first one or is it the second one? Raha.
You can factorize the second one but not the first one. Because the first one's negative. If you square any number, it can't be negative.
Oh, so close. It's actually the other way around. Because, in fact, you're right. You can't square any number that's a negative, but you can... Oh my god. Here we go. So, yes, you're right that you can't square a number that gets you a negative number, but this is one of the key parts if we're just visualizing it. If you visualize each graph, because the whole point of factorizing is that you should then be able to solve for the intercepts, right? If you visualize this graph here, that's down by 10, left by 3, smiley face. So if you think about it, left by 3, down by 10, here's your turning point, smiley face. That one should have, on a prediction, should have two intercepts. So it means you should be able to factorize it so that it ends up with two brackets. So hence you can further factorize it. Why can't you do it for this one? This is up by 3, right by 2, and it's also a smiley face. So right by 2, up by 3, turning points here. Smiley face implies that there would not be any x-intercepts. Which, if you were to solve this equation, if I gave you y equals x minus 2 squared plus 3, you can already see, to find the x-intercept, you'd let y equal to 0. And watch what happens when you let y equal to 0. Move the 3 across, and this is what Raha was saying. It's just that it wasn't in the correct spot here. See, notice there. Whatever x is, no matter what number you pick, every time you square it, there's not possibility of getting a negative 3. But on the other version, this one is possible. See, if I swap this around, and I ask you to find the y-intercept, or the x-intercept for this one, x plus 3 squared minus 10, let y equal to 0. And if you solve it, bring the 10 across. This is possible to do. Square of some number can equal to a positive 10. That's why this is likely to get you 2 solutions. Means there are x-intercepts, and hence you can factorize. But the other one you can't. All right, questions?
How did you figure out that it's like a
Because from exercise 7b, remember how we had this one?
Yeah.
So this tells you up or down. This tells you left or right. And then the number that's multiplying to the brackets, if it's positive, it's smile, and if it's negative, it's a reflection. And so I can see that the number in front of it is positive. That's why I knew it was a smiley shape. All right. So the question is, so do we know the second one you can't factorize further? I'm just going to delete that so you don't get confused. But the question is how? So the question wants you to factorize by completing the square. So this one you can. Anyone remember this type of problem? Because I gave it to you in first session back here. I gave you a technique and I said that I went from easy, medium, hard, and I gave you a year 11 version of it. This is the year 11 version that all of you, well, most of you did pretty well. Do you guys remember what is this one? Very good. What's that called again? What's the name of the technique? DOPS, difference of perfect squares. So if you remember, this was a squared minus b squared is equal to a minus b, a plus b. That's your typical year 11 version where students may not recognize from this step to go to the next step using this rule. That's already something squared minus, you've got the minus there. That's why the minus was important. And then 10, you just need to write it as something squared. So if I rewrote it again, it's x plus 3 squared. So that's my a. A is my x plus 3. Minus square of what will give you 10? Root 10. So that's my a and that's my b there. So using the rule, that gives me a, which is x plus 3, minus b, which is root 10. Sorry. And then the other one was a again, x plus 3 plus b, which is root 10. Right there. That's what they mean when they say factorize by completing the square. Okay, so going from this step to this step is what they mean by factorize. If they say complete the square, you stop here. If they say factorize, this is what they want. This one's not factorizable. I've shown you 2 ways. You can't do difference of perfect squares. Thanks, team. Please don't speak while I'm speaking. I find it highly disrespectful. Because you can wait till I finish. And then you can have your chat, which I'm usually okay with. But it's just not during the time I'm speaking. So right there, this one is not a difference of perfect squares problem. That's technically a sums of perfect squares, which we don't have a rule for it. Whereas this one, we do have a rule for difference of perfect squares. So you have to look out for that minus. The minus actually is the key step to it. And the minus is also the key step to why you can solve the equation. Okay? So in today's exercise, you're just practicing to go from this step to that bit. So understanding how to complete a square and then taking the next step, revising your DOPS. So revising your DOP skills to get to this step. Next exercise from there is then to solve that equation, which is null factor law. Okay, so that's why it's all building. You have to learn all your factorizing expanding skills, and then cross method being one of the more important ones. And this is your second one. So when you can't use a cross method, this is your second method to do. So if I gave you an equation where you can't use cross method or you can't use grouping method, that's the next way to do it. That's how you check if you can get two brackets or you can't, besides quadratic formula. Okay, quadratic formula is another exercise, but that's your second method if the first one doesn't work. Okay? Let's do one more, but there is a caveat. I don't know if you guys realize what the caveat is to this completing the square. There is only one thing you can do. There's a limitation to it. There's a limitation to completing the square. Notice all the problems I did for you. There's a pattern to all of them. 1. This is the key part. What do you notice about all of them? It's always x squared. And the reason why is because the rule, it's easier if A is just x, 1x. Because if A was any other number, that changes the middle number. Because if that was a 2x, then you can't just rely on the fact that doubling 3 will get you the middle number. So A, ideally you want it to be just x. So it presents a problem then. When you get problems like this one, that one is not the same as every other one that you did. So this one here, 2x squared minus 5x, and you've got a plus 1. This is a problem. Because when you try to figure out what goes inside the brackets, it's not just half of -5, because we don't know what A can be. Okay, because A currently is now going to be 2x or root 2x. That becomes a problem. So the limitation of completing the square is the number in front of x squared needs to be 1, or the coefficient of x squared has to be 1, okay, for this rule to work. So how do you solve this problem then? If you've got a 2 or a 3 or a fraction, there's only one way. And this is where your fraction skills have to be good, and that's where the mainstream normally struggles at this point. So here, this is what you do. Take out the 2 as a common factor, even though there is no common factor. 2 times what gives you x squared? 2x squared. It has to be x squared. 2 times what will give you -5x? Very good. So it's -5 on 2x. And that's what I mean. So you have to be comfortable with fractions here. 2 times what will give you 1? 1/2. Now, notice here inside the brackets, the coefficient of x squared is 1. Now you can complete the square. So this is a bit more of a nasty one. So from this step, keep the 2. Your notation is important. So I'm going to do massive brackets out here. This is what you're trying to factorize, completing the square. So this is what I have. I have x squared. I have a -5 on 2x. And I have a plus half. Question is, what should the last number be in order for me to have a perfect square? Close. You're missing one step. So what did we do before? What do you have to do? Good. -5 on 2. You got to half this, remember? So that middle term, half that. This is why your fractions have to be good. What's half of -5 on 2? -5 on 4. So this now becomes -5 on 4. See, twice of -5 on 4 will give you this. Then the last number must be, what's the missing number? Oh no. What's the missing number here? We've got 2 missing numbers that we need. So remember, how do you find the last 2 numbers again? Not +5 and 4. Square. So remember, half this gives you this. Square of this gives you the last number, yeah? So to get that last number, it's the square of -5 on 4. That's what I mean. So you guys can work with whole numbers, but when it comes to the fractions bit, students get confused. Half the middle to get here, square that number to get the last number. So square of -5 on 4 means -5 on 4 times -5 on 4 gives you plus 25 on 16. That's the number I need. I need a plus 25 and 16. Unfortunately, I have a plus half. So since I added on 25 on 16, I need to now subtract 25 and 16. Exactly the same way as I did before. Except it's in fractions now. This is the second bit. Negative 25 and 16 plus half. Again, going back to your fractions. You can times this by 8. Times that by 8. That now gives you negative 25 plus 8. Negative 17 over 16. Almost done. Last bit. See, notice how you got two terms in the brackets? Expand it. 2 times this term and then 2 times this term. If you do that, you should get now 2 bracket x minus 5 on 4 squared. And the 2 and the times the negative 17 on 16 becomes minus 17 on 8. Because the 2 and the 16 cancels out. That is now completing the square. And then from here you can do difference of perfect squares, which is nasty. Okay, this is where you can do dots. But up to that step, that is completing the square. So it gets trickier when you have a number that's not 1. Okay? So if you visualize that graph, down by 17 on 8, to the right by 5 on 4, smiley face, and it's a bit thin. Okay? This is like expected level at year 11 when you come in. But I know most students don't know how to do that. Yeah. It's gonna be, yeah, it's got a lot of, but that's how I know. So when you come in, this is one of the first skills I look at. I look at your fractions, I look at your algebra, I look at your layout. It tells me a lot about you, just from that one question. Okay? Yeah, and that's practice. As you practice, you get better at this. But leave these kind of problems to last. You have to build your first skills at the start. So I said completing the square, most students struggle the first time. So practice, whole numbers first. Pick the ones with even numbers. So in the middle, if the middle number is an even number, it's easier as well. So when that's an even number, it's easier to half. But once you're feeling comfortable with the technique, then try odd numbers and then try the one with coefficients. So have a look at that exercise. I can chuck in a year 11 question, like exercise as well, so you can see how it's very similar, but they just practice more of that. Okay, so you just got to do more of those problems. I'll stop the video there because I know it's quite a bit to take in, so I'm going to stop there, okay?